All right, so moving on to a new section today, we're going to be going through section 3.1. So we're looking at integers. Integers, we're just talking about all of our counting numbers and whole numbers, so 0 and on, so 0, 1, 2, 3, 4, all of our whole numbers that are 0 and above, and we're also now including the other direction, so we're going into negative numbers. So what we're going to cover today is how to locate positive and negative numbers on a number line. We're going to order those positive and negative numbers, find the opposites, and so we'll talk about that soon. Simplifying expressions with absolute value. This can get a little bit tricky for students, but it shouldn't be too hard if we're thinking about it in the context of integers. And then, as per usual, we're going to translate word phrases to expressions with integers. So what are the actual purposes of negative numbers? So there's a few different applications we think about. We can have temperature. So we can have negative 10 degrees, negative 5 degrees, 0 degrees, 5 degrees. And so we really need integers to encompass all of those different ranges. Another example would be altitude. If I set my sea level as 0, then I can go up from that if I want to go and elevate in my altitude, or I can go below that if I want to look at depth of the ocean or whatnot. And so you can get things like negative 500 feet as displayed in the image on the right-hand side. Or you could have positive 500 feet or 1,000 feet, going into the mountains. You could have 8,000 feet. All of these different values are things we need to be able to represent. And so we need positive and negative numbers from now on. And being able to represent those using number lines is super important. So before we had a number line that began at 0 and went to the right. Now, if we can look at our number line, we have this extension to the left, which passes 0 to the left, we would get our negative numbers. And so you can see that 0 is not included as a negative or a positive number. So 0 is 0, but we need to be able to use the negative portion of this number line appropriately. Another thing you may notice is we have 1 here, negative 1. Then we have 2, negative 2. And so these are what are known as opposites. So 2 has the opposite of negative 2, which means it's still 2 from 0, but it's just in the opposite direction. So plot the numbers on a number line, 3, negative 3, negative 2. So we start off by just drawing our number line. Now, I will put 0 in the center. Then from there, I know that I need to go up to positive 3. So maybe I'll go 1, 2, 3, 4. Now, because we know that this number line continues on, we would then put our little arrow there. And we can put 1, 2, 3, and 4. Now we need to go to negative 3 and negative 2. And so we want to go to the left of 0. And so we would have negative 1, negative 2, negative 3, negative 4. And then it would continue on theoretically. We just don't need to use that much today. So that would be negative 1, negative 2, negative 3, negative 4. And so here you should be able to see that our negatives are going to be our values left. So the way that we denote this is by putting our little minus sign or our negative sign. And then we put the amount of distance away from 0 it is. So 1 unit, 2 units, 3 units. So if we're going to the left, it'll be negative 3 units. And to plot these points, all we're going to do is draw a little circle filled in at these points. So if I look for point 3, I would then go and plot that there on 3. Negative 3, I would go to negative 3, and I would plot that point there. And the same thing with negative 2. If you're being asked to do this in some kind of test situation, please make sure that you accurately map out the distance between each point. Obviously, you can see here and here are really not the same distance from 0. I've just eyed that and I haven't done a very good job in that specific section. So just measure it out, maybe put a centimeter in between each mark. So when we're looking at ordering number lines or ordering positive and negative numbers using the number line, we can think of our going further and further to the right or further and further positive as increasing. Then we have decreasing is further and further to the left. So the numbers are getting more and more negative. So that's what's called a decrease. So from a few lectures ago when we were talking about inequalities, which hopefully you've had a look at, you need to be able to use the less than or greater than symbols to denote or order these pairs. So less than, so remember that means further to the left on the number line. So 14 and 6, if we were to draw a number line, we would then say 6, maybe here, is 14 going to be to the right or to the left of 6? Well, it's increasing. It's a larger number. So maybe it would be down here. And so therefore 14 would be greater than 6. -1 and 9. We'll think of a number line. If I just set this up and I put 0 here, -1 would be to the left of that, being a negative number. And +9, maybe if I extend it down to make it a little bit more realistic, maybe it would be down there. Now you can see because we have -1 and then it is we'd use some relational operator, so less than or greater than. And so we could say that because -1 is further to the left than 9, it must be less than 9. And so that's how we denote that. Then using this same number line, let's just plot -4. And so -1, -2, -3, -4. We can see -4 might be somewhere down there. And since we're relating -1 to -4, -1 is further to the right. So it's a larger number than -4. So it must be greater than. Now just with a last little number line, we want to plot 2. So let's say 2 is here, and then we plot -20. And so you can see that -20 is significantly further to the left, or significantly smaller or decreased than 2. And so therefore 2 would be greater than -20. So basically you can think of, if I draw an arrow from 6 or from 14 to 6, I have to go left, which means that 14 must be larger than 6. Here, if I go from -1 to 9, if I go 9 and I go to -1, -1 is to the left of 9. Therefore, if I'm relating -1 to 9, it has to be less than. And you can continue this pattern on, but the basic premise is if it's to the right of the number, if it's further to the right along the number line, that number that is further to the right will be greater than. If the number is to the left and it's relating to a number which is further to the right, then it must be less than. So extending upon what I spoke about before, we have this concept of opposites. And so the opposite of a number is just a number that is the same distance from 0 on the number line, but on the opposite side. And so on this example on the right, you can see that -2 and +2 are opposites because they're both 2 from 0, just in different directions. So -2 is 2 to the left. +2 is 2 to the right. And that's the same you can see with 3 and -3. So 3 would be to the right of 0, 3 units. -3 would be 3 to the left of 0. So find the opposite of each number. So 7, remember we're relating it to 0. So if 7 is 7 units to the right of 0, -7 is 7 units to the left of 0. Therefore its opposite would be -7. -10, well this is 10 units to the left of 0. So therefore +10 would be 10 units to the right of 0. So now just to take a break for a quick second and talk about the notation. So we're using the subtraction symbol. So we're using the little dash across. And so you can see this in a few different contexts. So the first one is where we're indicating subtraction. So 10 minus 4, that indicates subtraction. Then, if we look at negative 8, that indicates negative. So it's the negative sign out the front of a number. The same thing here. However, if we have negative x, remember you would substitute in a value, be it positive or negative for x. And so what this means is you find x and it would be the opposite of x. So negative x would be opposite x. So just another note that it can also be in front of a number. So negative 2 is still the opposite of 2. So negative x is the opposite of x. And so it's quite easy to see that it would be basically the same concept, but it is important to notice the difference. So here, this is probably the best example. If you have the opposite of negative 2, you already have a negative 2. Now the opposite of that would be positive 2. So simplify the opposite of negative 6. So negative 6 would be 6 units to the left of 0. Therefore, the opposite must be 6 units to the right of 0. And so this would become 6. Another key way to remember this really is if you have a negative symbol and a negative symbol, they cancel and become a positive. And so therefore we get positive 6. So what are integers? I kind of spoke about this earlier, but integers are just the counting numbers. So 1, 2, 3, 4, 5, so on. They're opposites. So negative 1, negative 2, negative 3, negative 4, negative 5, and then 0. So we're including 0 as well. So evaluate negative x, or the opposite of x. So when x equals 8, the way that I would work this out would be I'd put our negative and then I'd put our brackets. And so x is equal to 8. Therefore, the opposite of 8 would be negative 8. Now, same thing here. We've still got negative and then our brackets. Now in this case, our x is negative 8. The opposite of negative 8 is positive 8. Therefore, we get positive 8. So now simplifying expressions with absolute value. So we've actually spoken about this, but we haven't spoken about it properly, or I haven't put in a name to it. So absolute value is just a way of expressing the fact that we've moved either to the left or the right of 0 a certain number of digits. So if I move to the left 5 units, that would be negative 5. If I move to the right 5 units, that would be positive 5. The absolute value then says, okay, don't worry about whether it's positive or negative. What is the actual distance from 0? It's just 5 units, so it'll just be 5. So here you can see on the number line, we've just got this distance of 5 units to the left and 5 units to the right. So therefore, can this ever be negative? Can the absolute value of a number ever be negative? Well, no, it can't. The whole purpose is it simplifies negatives and positives down to the actual distance from 0. And so you'll never get an absolute value that is less than 0. You can have an absolute value that is 0 if you are still at the origin, or if you're still at 0, because then you haven't moved from that space. If it was 1, the absolute value was 1, you would have moved either left or right 1 unit. But potentially it didn't matter in this case, in the sense of it didn't matter whether we went to the left or we went to the right. It just matters that we went 1 unit. So finally, the last thing, which is super important, is when we're using our PEMDAS or our BOMDAS or BODMAS or any of the other ones that we can use, the absolute values are treated as a bracket or a parentheses. So let's work through some examples for that. So simplify the absolute value of 3. Or remember, it just means right now we've got positive 3, and so the absolute value is just 3. Meaning we've moved 3 units from the origin or from 0. The absolute value of negative 44 would be just 44. It's not necessarily positive 44, it's just 44. And the absolute value of 0 would just be 0. So to recap, these, the 3, the 44, and the 0 are the units that we've moved from the origin or from 0. They don't have a direction. So evaluate the absolute value of x when x equals negative 35. And so I would just write our absolute value symbol and then we substitute in. So we've got negative 35. Remember, that just means we've moved 35 units from the origin. So that would be the absolute value. The absolute value of negative y. So I'll put my brackets there and then our absolute value symbol around. Now I'm going to substitute in negative 20 for y. So therefore, we get the opposite of negative 20, which is positive 20. And then we evaluate the absolute value. Remember, it doesn't really matter about signs. So realistically, I can just get rid of that, and the number is just going to be the important part. Now here, I've got the opposite of the absolute value of u. Now u is equal to 12. Remember, we evaluate what's inside the absolute value first, which is just going to be 12. But the opposite of 12 would be negative 12. So this is where your orders of operation really come in handy. Yes, we are saying it doesn't have a direction when we're evaluating the absolute value, but we've got the negative or the opposite symbol outside of that absolute value, meaning we evaluate that after. So now we've got the opposite of the absolute value of p. And then we've got p is negative 14. So remember, we evaluate the absolute value first. So the absolute value of negative 14 is just 14. And then we carry that negative symbol, or the opposite of 14 will be negative 14. And so that's the answer that we get there. So now we're filling in the less than symbol, greater than symbol, or the equal sign for each of the following. So let's reevaluate this step by step before we determine whether they are less than, greater than, or equal to. So starting with our left side, the absolute value of negative 5 is just going to be 5. And then the absolute value of negative 5 is going to be 5, but then we've got an opposite symbol, which would be negative 5. And so we can see that 5 would be greater than negative 5. If you have any trouble with the greater than or less than symbols, there is a video in section 2 on inequalities, so I suggest go checking that out. So now we've got 8. Now 8, there's no evaluating to do, but on the right hand side, we have the absolute value of negative 8, which would just be 8, and then we've got a negative in front of that, or the opposite. And so this would also be greater than. Now for C, we've got negative 9, and then we've got the absolute value of negative 9, which would be 9, and then we've got a negative or an opposite symbol in front of it, which would then bring it back to negative 9. And so we can say the left-hand side and the right-hand side are equal to each other. So negative 9 equals negative 9. And for question D, we have the absolute value of negative 7, which would be 7, and then we have a negative symbol in front. Then on the right-hand side, we end up with negative 7, and so therefore we end up with the same thing on both sides again, and so they'll be equal to each other. All right, to extend upon the concepts we've touched on so far, we can now evaluate different expressions inside of our absolute value symbol. So remember, our absolute value in the grand scheme of things is part of our brackets, so we do that first. What that means is anything that's inside, we also need to simplify first. So for A, before we can calculate the absolute value of 9 minus 3, we need to actually calculate 9 minus 3. So first, you would get the absolute value of 6, which would then be 6. So here, we would end up with 4, and now, because we don't have anything there, remember these act as parentheses, which means this is a multiplication there. Now the absolute value of -2 would just be 2, which means that we have 8 as our answer. Simplify this expression, the absolute value of 8 plus 7, subtract the absolute value of 5 plus 6. So remember, we just want to simplify inside our absolute values first. So 8 plus 7 would be 15. So we have the absolute value of 15. Subtract the absolute value of 5 plus 6 is going to be 11. And so that's what we'd end up with. Now the absolute value of 15 would just be 15. And then the absolute value of 11 would be 11. And ultimately what we would get would be 15 minus 11, which is 4. Now a little bit harder. So we've got an absolute value, and then we've got parentheses and some subtraction inside. So remember our PEMDAS or BOMDAS, we need to work on our innermost brackets first, remembering that our absolute value symbols count as a bracket. So we can rewrite the expression 24 minus the absolute value of 19 minus 3 times, and so inside this bracket we need to actually calculate first. And so 6 minus 2 will be 4. Now the next thing we want to work on is our multiplication inside our absolute value. And so we'll rewrite that again. 19 minus, and 3 times 4 is 12. Now we can calculate the 19 minus 12 inside our absolute value. And we end up with the absolute value of 7. Now our absolute value of 7 is just 7, which means 24 minus 7. And 24 minus 7 will be 17. And so ultimately this big expression above with absolute values and parentheses all evaluates down to 17. So now we want to look at translating word phrases into expressions with integers. So the key thing here is we're going to be looking at the same expressions that we've been working on all through section 1 and section 2. So if you need a refresher, have a look back at those videos from section 1 especially, where we worked through all of our basic word phrases. But ultimately, in this is because it's an extension of, we're using negative numbers. We're going to be looking for words that indicate opposites or negativity. So translate each phrase into an expression with integers. So the opposite of positive 14. So we would have the opposite, which is the negative symbol, and then we would have positive 14 in brackets. This would then evaluate to negative 14. So now for B, we've got the opposite of negative 11. So we first want our opposite symbol, and then we can put our parentheses and then put negative 11. So remember, an easy way to remember this is negative and negative become positive. So the opposite of negative 11 will also be positive 11. For C, we have negative 16. Remember, that's just our negative symbol and our 16 in front, or behind it technically. And now for D, we have 2 minus negative 7. So 2 minus and then negative 7 in brackets. When we evaluate this, we would then get 2 plus 7. Remember, the opposite of negative 7 would then be positive 7, and so we would end up turning that to an addition. So you can try and remember it that way if you can. So a negative and a negative become a positive, and so we use the plus operator. 2 plus 7 would then equal 9. All right, so translate into expressions with integers again. So let's look at question A. The temperature is 12 degrees Celsius below 0. And so the way that I would say this would be 0 minus 12, which would then be just negative 12. If we wanted to be specific, we could then write our negative degrees or negative 12 degrees Celsius. For B, the football team had a gain of 20 meters. So we could then write positive 20. We could write our little plus, we could write our meters. Now, the elevation of the Dead Sea is 1,302 feet below sea level. Remember, we measure sea level from 0, And then because we're going below sea level, we would then subtract 1,302 feet. And so remember, negative, subtraction are interchangeable. So if you see negatives, they also mean subtraction if you're subtracting from something. And so you would end up with negative 1,302 feet. Now for D, a debit account is overdrawn by $40. To be overdrawn means to be in the negatives. You owe $40. And so if we think of 0 as our base or benchmark, we would then subtract $40 to indicate how much money we actually have. And so we'd end up with negative $40. All right, that brings us to the end of this lecture. Hopefully you found some usefulness or utility out of that. Negatives can be difficult to work with, but when you start and think about opposites and the opposite of a negative being a positive, it should kind of click and become quite second nature to you. It is very, very important to get really comfortable with negatives and opposites, because in algebra, one of the biggest things I see is sign errors. And so if you can get this down pat, you're in a good position to do well.